Here we'll discuss probability distributions, in particular discrete probability distributions. Before we start this, we need to define something known as a random variable. A random variable is simply a variable whose values are determined by chance. That chance can vary depending on what we're talking about, but anything that's decided based on chance. Now that we have a random variable, we'll discuss a discrete probability distribution. And for a discrete probability distribution, our random variable does need to be a discrete value. A discrete probability distribution consists of two things. The first are the values that the random variable can assume, and the second, the corresponding probabilities. These can be written as either two rows or two columns, depending on if you want a vertical or a horizontal table. We will do ours horizontally, which means we'll have two rows for all of our distributions. Let's consider the experiment of rolling a standard six-sided die. Well, our probability distribution has two things. The first are the variables that we can assume. A standard die can roll a 1, 2, 3, 4, 5, or a 6. Assuming this is a standard die, the probabilities of each of these will be 1/6. So now we have our probability distribution. Next, we'll consider the case of tossing two coins. Well, we do need our random variables to be discrete values for this, so we can't just look at heads and tails, but we can let x be equal to an actual discrete value, like the number of heads that we flip. We could have also done the number of tails, but in this case we'll look at heads. We could flip 0 or 1 or 2 heads. We do need to think about the probability, and if we think about the different outcomes that could occur by flipping two coins, we can see that there are 4 options. To flip 0, there are 1 out of 4. Ways to flip 2 heads, or 1 head rather, would be 2 out of 4, and then 2 is just 1 out of 4. The next one we'll do is the case of having 3 children. Once again, we'll have to let x be equal to one of the two cases here. We'll let x be equal to the number of girls that are born. Out of 3 kids, we could have 0, 1, 2, or 3 girls. If we have 0, there's only one way to do that, and there will be 8 different possibilities here. The one way is to have 3 boys. Equivalently, the one way to have 3 girls is to just have 3 girls. There's only one way. If I think of the different ways to have 1 girl, she could be born first, second, or third, meaning there are 3 out of 8 ways. Having 2 girls is the same thing as having 1 boy, so once again this will be 3/8. We could have also done this by listing out the possible outcomes with 3 children and recognizing these different probabilities the same way we did with the head and tails flipping of the coin. There are 2 requirements for these distributions, one of which is the sum of the probabilities has to be 0, or not 0, rather 1. Has to be 1. The sum of your probabilities is always 1. So that second row has to always be 1. In addition, probabilities always have to be between 0 and 1. They can include 0 and can include 1, but they have to be between 0 and 1. Here, we just want to know, is this a probability distribution? The second rule is the easiest one to check. We can see that all these numbers are between 0 and 1. So now we just need to add them up and see if we get 1. 0.3 plus 0.23 would be 0.53. Plus 0.41 is now 0.94, plus 0.06 is 1. So yes, this is a probability distribution. Here is another one, and once again we can see that all these numbers are between 0 and 1, so that's nice. However, if we add them up, 0.29 plus 0.16 is 0.45, plus 0.48 gives us 0.93, and then when I add 0.13, I get 1.06 rather than 1. So this is not a probability distribution. For our last example, we'll look at this one, and we can see that we have this number that's bigger than 1 and a negative number, which tells us that no, this is not a probability distribution. If you add these numbers up, you still get 1, but we do need both conditions to be true, and in this case, only one of them is.